Well, good morning, good afternoon, good evening, wherever around the world you are. And welcome again to Microsoft Zero to Hero stage. So I'm so happy that I'm in this stage again. I just got back from vacation, and this is the first session after my long vacation. It's really energetic, when every time that kick off the session with the intro video, it's like pumping up the heartbeat, and it's amazing to be part of this great community together with the amazing people that we are came together again, and we are going to talk about another interesting topic about Microsoft Cloud technology. So I don't want to spend too much talking about what I've had in my vacation, but we have another great session today with a very interesting topic. I really love to learn more about this great topic today, which Florian Lenz will talk about a global distributed application in Azure Cloud Architect for high availability and low latency. It's very important topic because if you learn a lot from Florian, you can build a lot of solution, and he's going to demonstrate a lot of best practices for you. So I'm really looking forward for that. With that said, let's start with my normal presentation. So Microsoft Learn. I believe most of you already know about Microsoft Learn community, and learning rooms. This is a great opportunity for you if you can be part of that, and you can get understanding about technology, learning from experts. And if you have something to share, this is a great place that you can share your knowledge with rest of people in the community. Beside that, if you're part of Microsoft Learn community, you can get latest updates, news, changes, and you can have a great place to join conversation with rest of people around the world. And it's a great place that you can learn and share. So basically, as we always say, make Microsoft Learn your homepage. So every time that you want to learn something, it's a great place that you can learn more about that. With that said, if you want to learn more about Microsoft Learn community, aka.ms Microsoft Learn community, or if you want to join to Microsoft Zero to Hero learning room, aka.ms join Zero to Hero, is the short link that you can use that, fill it out the form, and after 24 hours you will join to Microsoft Zero to Hero community. Also, we have more learning rooms. So if you want to check other learning rooms, just check ak.ms/learning rooms, so you can find which room that you would like to be part of that. So we're trying to cover all of topics around Microsoft cloud technologies. Uh, Today is the last session of August. However, if you haven't registered for our sessions in September, make sure that you follow our links in social medias, especially LinkedIn. You can find all of those registration links that you need to basically find in September sessions. We have good speakers. We are going to talk about other interesting topics around different part of Microsoft Cloud technology, from Fabric to M365, Azure data, and so on. So don't miss those sessions as well. We are looking forward to see all of you in September as well. If you haven't heard about that yet, but just we recently released a new program called Microsoft Next Gen Heroes, which is leading by Microsoft Learn student ambassadors. And it's a great program that we're trying to inspire you that you are new in Microsoft cloud technology. It's a great opportunity for you. Even if you want to contribute for any type of sessions, we encourage you to be part of this program as well. And it's great opportunity for those individuals that they want to learn more about Microsoft technologies if you don't have any experience yet. So You can learn a lot with workshops that we are going to have or even live sessions. So make sure that you register for Microsoft Next Gen Heroes sessions as well. And the last slide, this is our code of conduct. So in Microsoft Zero to Hero live session, we expected you to be aware of others, be friendly, be welcoming and respectful, be open to all questions and viewpoints, be understanding of difference, and be kind and considerate to others. Perfect. So this was my last slide, and I bring our great speaker today. Hello, Florian. Welcome to Microsoft Zero to Hero stage, man.
Hi. I hope everything is fine.
Yeah, everything is great, and we are so happy and looking forward for your great session with this interesting topic. I'm personally looking forward because I'm going to learn a lot of things from your experience about this interesting topic. But before you start, I have a question from you. What do you think about Microsoft Learn? Why people need to learn about Microsoft Learn, or they have to make Microsoft Learn as their homepage?
Yeah, I mean, we talked already in upfront, and for me, the highly important thing in software development industry is to learn from time to time. And honestly, I told you as well, I learn every time I'm staying on stage and making a presentation. I learn something new. I have colleagues which learn from time to time, and for me, I think it's a great idea to have such a community and have a place where you can learn and you can search what you want to learn. So, for example, if it's AI or if it's serverless, whatever. So, for me, learning is I would say, a good software developer want to learn every year, every day. So, this is my opinion.
Amazing. Yeah, that's very true. That's very true. Perfect. So it's time that you start your presentation about this interesting topic. But before that, people, if you have any questions, just ask from Florian, and the best question will our winner to have Microsoft exam voucher discount for fundamental and advanced exam. So bring your question to the stage, and Florian is here to answer your question at the end of the presentation. So Florian, good luck with your session, and I'm here in backstage if you need me. Okay?
All right. Thank you. So, hello everybody from my side. We will talk about the topic of global distributed applications, or how I would pronounce it, serverless edge computing. And I will show you something about global distributed applications. So, from my perspective, edge computing. And I will show you why I would use serverless in such a use case. And this talk is a more advanced topic. So when you are completely new to Azure, maybe from time to time you don't know what I did, just write it in the chat, not a problem. Maybe afterwards we can have a short chat, or I will explain something. So from my side, we can start. I'm Florian. I'm a freelance software developer, cloud architect, you name it. Most of the time, I'm architecting cloud solutions and serverless solutions for my clients. And in the last years, mostly it's serverless. And I have the feeling that from time to time, a lot of companies starting with serverless, or they want to try something out in serverless. And so it started in my mind like, okay, serverless is quite nice to just make an application with it, but where are the real strengths of serverless? Where can I use serverless, and where other solutions are not that good as serverless? And so I decided to have a look and doing some research, and then I found out that global distributed applications could be such a use case where serverless is a good solution. And this is what I will talk about today and what I want to bring to you today. So first of all, I made a little bit of research, as I told you, and I found a research from Google that Google made a study to have a look how does the bounce rate of applications or websites increases or decrease by the load time. And they found out that a load time up to 1 second is more or less not a problem. Because you as a customer, when you go to a website, for example, 1 second or less than a second, you do not really feel it. It's mostly like real time, mostly. But from 1 second up to 3 seconds, so when the load time increases from 1 second to 3 seconds, the increase of bounce rates is by 32%, which means, for example, when you have 1,000 customers and your load time is between 1 and 3 seconds, you have approximately 300 customers who will leave your application just because your load time is too high. So, and I mean, Google did this research, they have a lot of numbers. So what we can make with this information, having a look to our response time. Is our load times, our response time fast enough? And this is, for me, something we can fulfill with a global distributed application. And I will show you now as well why I think this is something we can check. So maybe you know already this diagram. I guess it's from Microsoft, honestly. And what we want to have is, for example, the following. We have multiple applications, so app services with a Cosmos DB in Europe, in USA, not in Brazil, in India, and in Australia. And for example, as I said, in USA, there is no application, but we have a customer in the USA. And as you can see, I made a little bit of research, and depending on which real location it is, it takes 200 to 300 milliseconds to make a request, for example, from the USA to Europe and back to the customer with a response, which means that nearly 1/3 of our load time is only inside the wire, and because of physics. So we have at the end 300 or up to 300 milliseconds just load time, because our application is, for example, only in Europe and not in the USA. So the idea of a global distributed application should be that we bring our application close to our customers. So as you can see, in Europe and India, we have applications quite close to our customers, and the latency just by the latency just by the wire and the physical stuff, it's 20 milliseconds around. So at the end, we are quite faster, and hopefully we don't lose customers just because our application is too slow. But there is another fact I found, and the other fact is that, for example, Amazon, I guess it was in 2018, goes down and loses $66,000 per minute. And when I'm right, it was half an hour that Amazon was down, which means approximately $2 million is what they lost in such a downtime phase. And I mean, for sure, this is a quite big company, and Amazon earns money by selling products on Amazon.com. So basically, when you don't have an application where you sell something like an online shop, this is maybe not the problem, or not a problem you will have. But it could be as well when you just have, or I mean, it depends highly on your product, on your application. So for example, when you have an application like Amazon, so an online shop, or like Uber, where someone can buy a taxi and pay in the app, then a downtime phase could lose you money. On the other hand, when you just have an nice to have app, I would say. So for example, for my car, I have an application on my phone so that I can open the door, close the door, whatever. And I mean, it's just nice to have. It's not really necessary for the car to drive with the car, which is honestly the reason I bought it, and not the app. Then the company won't lose money when the app is not available. That's right. But maybe, the prestige is going down. And me as a customer, I would say, all the time I want to use the app, the application is not available. It doesn't feel high quality, and maybe I will choose another car next time. So So it's not always about money, but for sure prestige you can lose when your system is not available. But as well, high availability is some kind of buzzword, I would say, and not every application needs to be high available. But have this in mind that high availability could be a requirement for your application, and then as well a global distributed application could be a solution for you. So, topic of high availability, we just added or we lost a lot of applications. We have an environment with 5 applications, and 3 of these applications are down. So what happened when we don't have multiple applications? When one application is available and this one application goes down, none of our customers can go to our application, which means, we have a downtime, we lost money, prestige, whatever. When we have an application, a global distributed application, as you can see, we still have 2 applications up and running, and in best case, these 2 applications can fulfill all the requests and can handle the requests, and the customer doesn't really recognize these downtimes from other services. The only thing they may recognize is, for example, that a customer from the USA has a little bit bad performance instead of normal cases, but it's still better in case having a lower performance instead, no performance because there was no server available. So, as I said, this is the idea we want to do today. At the end, we have multiple applications or one application distributed to multiple regions. And the idea is that our customers, which sit around the world, can go to our applications as fast as possible. And for sure, when there are some downtimes, they just don't recognize and can use our application as they want. So, and now we start a little with serverless, I would say. Or first, what is the idea when we do a global distributed application in the normal way? It would be something like we just use VMs, for example. For sure, we can have, for example, Azure App Services or Kubernetes and Docker, etc. But today I'm mostly focusing on VMs. So we have VMs, as you can see. The 6 VMs currently, and we have 2 in the USA and 2 in Europe, and 1 in Brazil and 1 in Australia. And in the classic way, we pay for each VM. So for example, we pay $30 per month. This is just an example. Honestly, when you have a high load application, you won't pay $30 per month per VM. It's quite more. But to start with it, it's quite okay. So, and under normal circumstances, what we can do now is just adding more and more VMs. So for example, we have customers in South Africa. Maybe we want to add their VM as well. Maybe in India, we have customers, and Singapore, we want to add their VMs as well. And every time we need to pay more and more and more. And this could lead, or in this example, we pay a $182,000 per month, every month, no matter how many users the application uses. So for example, the application of my car brand, when no one is using the application, they still need to pay this money. And I mean, maybe it's not $182, but maybe it could be $2,000 or $10,000 every month for nothing, or maybe for a few customers or a lot of customers, but you pay it no matter how many traffic there is. So, and when you have a look to serverless and serverful, so VMs are serverful and Azure Functions, for example, are serverless. On the right side, you see this serverful approach. And when you have a VM, you pay, as I said, you have this baseline of, for example, $180 per month, but the traffic of your application is quite lower. So you have, for example, as you can see, the graph, you have some waste, and the waste is, as you can see, not that it's quite much, honestly. So it's not less, and you pay for it. So when you have, for example, a bigger machine with $2,000 per month, you still need to pay it, and maybe it's a quite same diagram, and there's still waste. So you cannot have a VM which is, 80-90% under load, and you have only a little bit waste. This is honestly not possible because you always have some more load and less load. So this is what it This is what it is in serverful. On the other side, serverless, or I would say basically today mostly in Azure Functions, you pay only for the request you have. So as you can see, you have traffic, it's going up and down and up and down and a little bit more up and more and more. You pay only for this new addition of requests. And when it goes down, you pay less. And yeah, the red area is, so the waste is quite less than on the server full approach, which means it could be more cost effective. And all the time I hear, yeah, okay, but on higher numbers and when you have millions of requests, server full, so VMs are quite better because you pay only you pay only monthly and not per request. And for example, 100 million requests in serverless is quite costly because you have 1 million requests you need to pay. And therefore, I will show you a diagram I made. But at the moment, the quite easiest definition is server full, you pay monthly, and serverless, you pay per request. I tried to find an anecdote for this, and the only thing I found was have a look to Netflix, for example, or a video streaming provider like Netflix. And there are two models you can use. The first model is a server full like model. So you pay $50 per month and you can watch every movie. You can watch 100 movies a month. You can watch one movie a month. Just don't care. You pay only the $50. On the other side, you have the serverless approach where you pay only per video. So for example, when you just watch two videos, you pay $2 because one per request, for example. And when you watch 100 movies, you pay $100, 1,000 movies, $1,000, etc. So it depends highly on how much you pay on your request you did, your movies you watch. And in this anecdote, you can think about, but then I have this point where it's cheaper to just use a serverful approach. And this is where I'm not 100% fine with these, because I found out that serverless could be cheaper in all the times, but this is just a cliffhanger for later. So, but when you use serverless, how can we change it? We can change it by, instead of using VMs, by using Azure Functions. And as I said, there is no monthly fee you pay, you just pay per request, which means you have a monthly cost of $0 when no one is using your application. And this as well when you have a new function app in India, in South Africa, and wherever you want. You can have 10 applications in the USA. It doesn't matter. You don't pay any money for it. But as well, as I said, per request. But the request, I don't have the numbers currently in mind, but it's less than a cent per request. It's about 0.001. I don't know. So it's not really much, honestly. And this is a diagram I made. And as you can see, when you have 1 million requests, you pay nothing for Azure Functions, the red line. And for VMs, you don't see it because the diagram is not good, but it's $75 per month for the VMs. And this is what you see here. So you see the difference between Azure Functions and VMs. And my assumption for the VM costs are that, for example, 1 million requests, which means we have 1 million requests per month divided by 30, so per day, divided by 25 per hour, so on and so on, so that you know how much requests do I have per second. Then I'm doing a little bit research and I'm using ChatGPT for getting some numbers. So for example, when an average requests take, for example, 200 milliseconds and it takes 100 MB of memory, which application or which VM do I need? And this is the numbers I get then with the Azure price calculator. And honestly, I'm quite impressive that until 300 million requests, there is no big difference. So honestly, you can use serverless or VMs. It doesn't take a lot of differences. The only thing is that for sure the number of VMs are less than the Azure functions. So when you have, for example, 20 Azure functions, the number is exactly the same. For VMs, I guess I calculated with 3 VMs, so one in Australia, one in West Europe, and one in East USA. So when you add a VM in Brazil, in India, and in South Africa, then you need to double the numbers, and then this is a complete different story. But what for me is most impressive, that between 300 million requests and 700 million requests, there is a bigger difference. And my only idea why this could happen is because, as you can see, or when I go back to this slide, we need to always have a margin on the peak of our assumptions. So when we have, for example, the user traffic, and we know the peak is around 80% of this of our VM, then you need to add some margin, because there could always be a bigger peak, and then you need to handle this traffic as well. So you have a margin, for example, 20%, so that you have a little bit space, that when more traffic is coming or when one VM is going down, that the rest of the VMs are still available and can handle all the traffic. And this means the more requests you have, the bigger machines you have, the bigger is the margin and the costs you have for nothing in worst case. And this is the only reason, or the only answer I found and I think about, that the more requests you have, the bigger is the margin and the waste you need to pay for. And quite impressive for 1 billion requests. Honestly, I never worked in a project where 1 billion requests are made per month. But in such a case, the difference between nearly $4,000 and $11,000 is quite high. And honestly, I thought it's more the different way, that at the beginning serverless is more cheaper, and afterwards it's going to the same numbers. Yes, this is more or less the reason why I would use serverless for a global distributed application. But feel free to ask questions or give me some other views to this topic. But these are the numbers why I would use serverless. And this is all about the theory of today, what we want to create now, because honestly, this is only theory. I don't like theory. You learn only when we do it practical. And this is why I made a really short, but a quite good example, I guess. And this is what we want to create today. We have Azure Cosmos DB, where I show you how you can create this Azure Cosmos DB to have it globally replicated. We have Azure Functions in East US, West Europe, and Australia Central, where we provision these Azure functions with a quite small response. And then at the end, we need some solution to make these application available to our customers. And for sure, we want to have the connection to the closest customer. So it doesn't make sense that, for example, a customer in Europe uses the functions in East US. So this doesn't make sense. So what we need is a content delivery network. In case of Azure, it's Azure Front Door, which leads our customers to the closest region, so that our customer have a low latency application visible for him. So basically, let's start with coding. This is all about my presentation. So by using Azure Cosmos DB, you have the following page. I already created it, and honestly, you can just create an Azure Cosmos DB. There is nothing I did in the settings at the beginning. The only thing you need to ensure is that you don't use the serverless approach. This is the only thing I don't like in this presentation, because I talk about serverless and then the Azure Cosmos DB cannot be serverless because of some restrictions of Microsoft. But in general, it's basically you pay these 4,000 RRUs, for example. It's not a big problem. But just to ensure, when you have a serverless Cosmos DB, you cannot have multiple write regions. You can only have multiple read regions and one write region. So when you go to the Replicate Data Globally tab, you see the following page. And as you can see, currently multiple write region is disabled. A multiple write region means in the current situation, we only have West Europe. And when we have our Azure function hosted in East US, for example, when we want to write to the database, the traffic is going to Europe and then back to the US, which can lead to bigger latency, slower application, etc. Depending on your requirements, it could be a fine solution to say, okay, we just have one write region, we have multiple read regions, so reads are quite fast, but our writes are a little bit slower, and this is fine. Or for example, you use something like messaging for this problem. There are solutions that you can use as well as serverless approach, but to show you the multiple write regions, as I said, I created the normal Azure Cosmos DB account. So, and what we can do now by having only one write region, we can select multiple read regions. And honestly, I don't know what I click here, but I just click something. And then you can see we have write region West Europe, and then we have read regions in West US 3, East US, Israel, UAE, North, South India, Australia, East, etc. And when I click on Save Now, all these regions get a replication of our database, and we can read from these regions. As I said, it's only read, so our reads would be quite fast. We don't have latency because the Cosmos DB is only in West Europe. But as I said, the writes are still slow. When we need multiple write regions, so a fast write, because we have, for example, a write to read ratio of 1:1, 50/50, then maybe it's a better idea to use multiple write regions. And in such a case, as I said, serverless is not available, then we can just enable multiple write regions. And then, as you can see, reads enabled, writes enabled, and all these regions are available for writes and reads. And as well, we could use availability zones. We can click it, but honestly, it doesn't make a lot of sense depending on your requirements. This is honestly more or less everything about Azure Cosmos DB. You have one connection string. You can use everything like always. Nothing changed. The only thing you need to ensure is that you selected the right regions. But when you use multiple write regions, multiple read regions, you need to be you need to ensure that the correct consistency level is selected for you. So what you can do is, currently we have, for example, only West Europe, and when we have a look here, average replication latency from West Europe to East US is 135 milliseconds, which means when we have read regions in the USA, in Brazil, wherever, it took some time until the data is visible there. And here, consistency comes into the game. For example, we have strong consistency. As you can see, it's basically what we use in a non-distributed application. We write something to West Europe, and in West Europe, in West Central USA, and in North Central USA, everything is there at the exact same time. We write red, we have everywhere red. We write blue, everywhere is blue, and so on and so on. And this is only working honestly, it's not really working today anymore. But you can select it. It takes some time because, as you see, we have, for example, to South Africa, as I told you already, we have some. Here we don't see it. Okay, but as I already show you, we have this average latency, which means when we have multiple regions, it took some time until the operation finished and we can read the data, which means we write red and we need to wait, and then after every replication gets the data, we can read the data and the write is done successfully. Then we can use bounded staleness, we can use sessions, we can use consistent prefix, and session is the default. And as you can see, it's, depending on the region and session. Honestly, have a look to the default consistency tab. Here, everything is, visible for you. And honestly, some guys hate these application, these GIF, but I love it because I learned how to, or which different consistency levels there are and how they work. And the completely opposite of strong is eventual. And here, as you can see, there is totally random data. So we write red, then blue, then in VS0 blue is visible, and then red. We just don't care about anything. This is something you need to have in mind when you want to use eventual. On the other side, the big advantage of eventual is that you write something and then the operation is immediately done and everything is fine. But when you read the data, it could take some time until you get the data. So when you use multiple regions, you need to have a look to this consistency level. And for sure, you need to go to your requirements, maybe ask your product owner, whoever, to get some more insights and decide which consistency level you want to use, which could suit your problem best. But this is not the topic, honestly, today. The topic is more about this geo-replication. And for database, as I already told you, you can just select the ones you want, and this is it. But then there is more. And what we can do is, starting with Azure Functions. First of all, we can start here. I created a resource group for today. And as you can see, we have some data. We have Azure Function for Azure 0 to Hero East US, West Europe, and Australia Central. And the only thing I did was creating a quite small application. We just returned the country, and this is it. I deployed this application to Australia Central. I changed it to West Europe, deployed it to West Europe, etc. You know what I did. And this is basically it. I mean, for sure, we can create big applications now, but just to show you the idea and how this global distribution is working, this is quite fine. And to test, we can just use Postman. And here, for example, we can use the West Europe API/get data. We can send the request and we get in 30 milliseconds, in 35 milliseconds, West Europe, which is quite fine, what we expected. Then we have East US. And when I sent data to East US, for sure, it took some time. It could be a cold start problem. Maybe you know it already from Azure Functions, but as you can see now, we have 100, 100. So we are around 100 milliseconds. And as you already could see, we have a difference of 70 milliseconds only because this is hosted in East US. As this one is hosted in West Europe, which is quite near to me because I'm living in Western Germany. So basically we have a little bit latency only because of the region of our software. And the same for Australia Central. Here the latency is a little bit higher, I guess. It's around 300 milliseconds. Nearly 300 milliseconds. So here is the first proof that it doesn't make sense to have a look to your customer base and have a look when your customer is living in Australia, for example, that your application, or at least your compute resources, should be close to your customers. As I said, the database could be in Europe, for example, when you're a Europe company and you use some messaging to ignore the right region problem. But in general, the application, so the request is made to your functions. The customer should be close to your function. So this is honestly, this is what I created. So there's nothing more. And as you can see, the differences in the latency. Now, what we want to create is for sure something like that. Me as a customer, I don't want to use an URL like Australia Central, and I don't want to use East US, for example. I mean, for sure, me as a customer, I just want to go to an application and I want to use the application. And in my mind, a customer doesn't care which endpoint is currently available. And we don't want to create an own solution for this. What we can use is the Azure front door. And Azure front door, you can just create this instance. There are more solutions, I would say, inside Azure front door, for example, web application firewall, rules engine, etc. Today, we don't talk about this. We only talk about the front door designer. And here, for example, we can add a front door, a front end, so a domain, and it's Azure 0 to Hero. And then Azure FD.net is the default host from Azure front door. Inside the backend pool, we have a list of functions. So what we have is our backends. Our backend is Australia Central, East US, West Europe. We can add more backends, and so for example, when we have India, we can add India as well. And then we can leave everything else. And then we need a routing rule, and here we have just called it location rule. And here we don't change anything as well. We use forward. This is important. And then we use the backend pool. In this case, it's functions, and we only use for forwarding the HTTPS, and then everything is fine. And per default, because we don't have any rules engine activated, this is now geolocation routing. So at the end, Azure front door ensures that our customer is redirected to the correct Azure function, so that at the end, the call to our application should be fast enough. So, and as you already saw, maybe we have this endpoint here. And when I go back to Postman, I can call this Azure 0 to Hero application. And when I do this, I get West Europe. So honestly, as expected, everything is fine. And as you can see here as well, it took a little bit time when we use Azure front door instead of don't using it. So when we have a look to the direct call of our West Europe instance, we have around 20 to 30. So in such an area, and when we use front door, we have around 30 to 40. But honestly, it's better instead of having 100 or 200 milliseconds. So at the end, we did the proof that our front door is working correctly. I'm living in Europe. I'm getting the West Europe application, so everything is fine. But I made, or I tried to simulate that I'm not in West Europe, and therefore I'm using Opera. And as you can see, this is a page where I see some data, and here, for example, it's currently Germany, everything is fine. And when I use the proxy and I select Azure, as you can see, then what we can do is calling this page again. And after some time, because now we are using this VPN proxy, we are sitting in Singapore. So from this perspective, the Azure front door now should use the either West Europe or Australia Central application based on which is faster. And as you can see, when I just reload the page, I don't change anything. We see Australia Central, which is quite fine. It looks like that Australia Central is closer than Europe. And when I change it to North America and South America, and I reload again, then as you can see, it's East US. So the application is redirected to East US. And basically, this is what front door is doing. So there is no magic, there is nothing else, everything is fine. We have most of the time a low latency application because, as you can see, a customer in USA will be redirected to East US and not to West Europe. But there's more. As I said, we have as well high availability. And let's go back to our applications. And for example, West Europe. And now to simulate that our application is not available anymore, we can just stop the application. And then we need to wait a few seconds. Sometimes, perfect. Sometimes we get a service unavailable. Sometimes we get data again. It takes some time. But when you go to the Azure front door URL again, you will see now exactly this is perfect that we get it. During a downtime, we have this short situation that Azure Front Door doesn't know that the application is down, and it took a little bit until Azure Front Door knows, okay, the application is not available anymore. They're doing health props, and yeah, when Azure Front Door recognize, okay, application is not available, we will be redirected to another application. So, and when we're doing some requests, as you can see, East-US is now what we get. Yeah, there's no proxy, etc. So at the end, we get the correct data. So it looks like as well East-US is closer to me than Australia Central. And this is exactly what I told you at the beginning. I have 300 milliseconds of latency, which is still quite good. But at the end, it's slower than going to the West Europe application. But I can use the application, I get data back, everything is fine. Maybe I have the feeling like the internet is not good today, but in general, I get data, I see anything. So, and then for sure, I can go back to the application, start it again. So yeah, application is back available as well here, a little bit time until the application is available. Now we see West Europe, and when we do some requests here as well, directly we see West Europe. So when the application is back up and running, we can get the data fast enough again, and we have a high available, low latency application globally distributed. So, and basically this is more or less everything, but I have two topics. The first one is a little bit security, and the second one is costs. The security topic is about, as you can see, we have this front door, and honestly, me personally, I as a solution architect would or don't want that any customer can call this application in West Europe, East US, and Australia Central. The only way to this application is through the through Azure Front Door. And maybe you think, this could be more complex, or this is with virtual networks, whatever. No, it's quite easy, and honestly, it should be the default for everyone who's using Azure Functions and Front Door. So what we can do in Azure Front Door, and for sure, this is the reason why we want it, we can have web application firewalls. I already talked about it, that Azure Front Door has this possibility, and we can add security stuff. We can ensure that there is no SQL injection, whatever. And when we have these web application firewalls activated, we don't want that any customer can just ignore it by calling our function directly. So when we want to ensure that our customers need to go through Azure Front Door, we can change it quite easy. And this is working like this. We can just go to our Azure function again, and inside the settings, we have the networking tab. And currently, when you go to public network access, everything is fine. There is no restriction. You can just call it, and everyone else as well. What you can do to ensure that this is not working, you can say enable with selected virtual networks, and then you say deny, and then you just add, for example, 9,000, say deny, and this is it. No, this is wrong, sorry. You can just say deny. So this is right, just say deny. After updating the access, no one can call this application. So the update is done. When we send this request, it took some time until the restriction is made, I guess. Right here, you can see already we have the priority, the highest number. We have deny all, and no one has access. And when this is fulfilled, took some time, but we can go further. So what we can do then, the application now has no access, but we want, as I told you, we want to have access through Azure Front Door. We can allow access from Azure Front Door. So for example, we say priority is 300, and we say type is service tag. And here we select Azure Front Door backend. And then it's only possible for Azure Front Door backends to call our application. So every Azure front door backend can call our application and has access to our application. I hope now we don't have access anymore. Yeah, right. You see 403 IP forbidden, exactly what we just created. So, and by using Azure front door, so now we are using Azure front door, you can see the same. So Azure front door is not available or cannot ensure that the data or the IP is available. So when you have this restriction, Azure front door knows, okay, Azure function is up and running. I just redirect it. So everything is fine. But then you get this forbidden. And with this, you need to change this one here, as I told you. And here is one setting important. And this is a x minus Azure minus FDID. Because when you don't set this property, in theory, every Azure front door backend can call your function. So a hacker, for example, could create an Azure front door instance without any web application firewall, make a request to your application, and then Azure says it's fine, it's an Azure front door instance which is calling this Azure function. So the traffic is okay, and your application is not secure. The web application firewall is not available then. So what you can do to ensure that only your Azure front door is available, you can take the front end ID of your Azure front door. And this is the front door ID here you can take, and you add this property here. And by adding this rule now, only your Azure front door has access to your Azure function, in this case, West Europe. And for sure, in general, you have, for example, ARM templates, infrastructure as code, etc. Then you don't need to do it manually in every Azure function. But here we need to do it for sure now in East US, Australia Central as well. And then only via the Azure front door, we can have access to our applications. By using infrastructure as code, it's quite easy for sure. So now by adding this rule, we can try to call our API again directly. It's still IP forbidden, so as we expected. And when we use our CDN, then we see East US, it's okay. And this will take a little bit until we get the West Europe data again, because now, based on these changes in the networking tab, there are some changes made. I will show you when it's done. But this is what I want to tell you about the security. So basically, when you use Azure Functions and Azure Front Door, please deny access directly through your application, because this is not what you want, honestly. And then the last one is the pricing. But first we try again here. Now we see West Europe. So as you see, West Europe, and here it's still forbidden. So as we expected. And now when we go to the pricing calculator, I made an assumption today. The first one is about Azure Front Door. Azure Front Door costs nearly $27 per month. This is quite okay, I would say, for a content delivery network. We have one routing rule. It's 24/7 available. Everything is fine. Okay, looks good. So no big deal. Honestly, for a company, not a number anybody should say, oh no, this is too much money. Second one, Azure Functions. And now it's going to be impressive, I would say. When we have a West US region and a consumption tier, as I said, the first 1 million executions are free, and 400 gigabytes seconds of each in aggregated executions. Which means when we have 100 million executions per month, and each execution takes 500 milliseconds and take 512 memory, then it costs us $400, nearly $400. And this number honestly is quite good for me, I would say, because 100 million requests is a quite high number. When you have a look to your system, maybe you see that you don't have these numbers. And on the other side, what is the solution when you don't use Azure Functions? When you have a VM, it took more than $400 to fulfill this. And here, it doesn't matter if this Azure function is only one function app in West Europe or if these function apps are spread around the world. So you pay just for the requests. And as well, when you have Azure Cosmos DB in East US, auto-scaled with multiple write regions, pay as you go, you pay for 400 request units per second in multiple write regions, and you pay for it in general, what was it, I guess, $2,200, which means, honestly, in general, when we close all tabs, for more or less $2,500 per month, you can have a global distributed application with Azure Cosmos DB, with multiple write regions, with a content delivery network, with Azure Functions, and consumption plan, etc. And yeah, when I have a look to my customers from time to time, they pay more than this, and they have more or less requests per month. And as well, this 4,000 request units per second, I made an assumption about it, so I guess it's okay. It could be that for 100 million requests you do, 4,000 request units is approximately the number we need. So from my opinion, this is a quite, could be the correct price when you really have 100 million requests per month. Basically, this is it from my side. So I'm done today. Thanks for watching. And now I will read the questions.
Amazing. Thank you so much, Florian. It was really great. We learned a lot about how we can leverage serverless solutions for different scenario that we might have in our environment. And it's important for people to understand how much they can leverage this solution for different type of implementation in their environment. So you explain it in a very good way. Thank you so much for sharing your information. As you mentioned, we have several questions actually. So let's start with the first one, which is from Upara, if I pronounce it correctly. So what is the advantage of moving from on-premises gateway to Azure gateway in architecture?
Oh, that's a good question. Honestly, I mean, when you are using Azure resources, my opinion is always try to be cloud native or Azure native. I don't know if this is correct, but take the most cloud resources you can use. In general, I would say maybe it's cheaper. I don't know, but at the end, for sure, you can make it as well with on-premises solutions. I mean, we talked about it at the beginning as well. It highly depends on your requirement at the end, and this is just a solution with some assumptions I made, but I don't know exactly every requirement, and there could be a reason to say no, we don't want to use everything in the cloud. Sure.
Okay. He asked another question, or she asked another question. If we open vendor ticket with Microsoft for any Azure cloud services issues, do we have to wait for the update on vendor tickets, or can we directly reach out to hotline number of Microsoft supporters for the region?
Honestly, this question is not something I can answer.
Yeah, that's true.
Sorry.
I think it's not kind of related question, but yeah. So let's go for the next one. Is there any advantage using serverless over serverful over serverless?
Yeah. As well, I'm working with serverless and I love serverless, but I'm realistic enough to say there is not a silver bullet, and as well, serverless is not the holy grail and you should use it every time, especially when you have when you exactly know your load of your application. So for example, you developing an application for your company, it's only used internally, and for example, you're a small company only in one region, for example, just Europe, and you are in the exact same time zone. And you know exactly when is a business application mostly used, maybe 8, maybe 7 in the morning until 7, 8 in the evening, and then most of the time in a nearly stable load window. In such a case, honestly, serverless is not really useful because the application, the load of the application is going up, and then it's staying there, and then after the time it's going down, and then this is it. And honestly, you can as well make some assumptions. So, for example, on weekends there is no load. On Christmas, for example, there would be no load, and then it's totally fine to make or to use a VM, for example, and just doing some scaling based on rules like scale up from one VM to 3 VMs at 7 in the morning on Monday to Friday, and scale down to 1 VM on Friday or every day on 7 a.m. from Monday to Friday, and stay on 1 VM over the weekend, for example. So in such a case, serverless is not, or from my expectation, not really necessary to use.
Yeah, exactly. And it's good to mention that Microsoft provided a kind of flow chart when you need to move from traditional or several full solution to serverless solution. It's part of CAF or cloud framework that sometimes we need to follow if we want to transit from traditional one to the new one, or let's say serverless. Maybe we need to re-architect our software or application to be able to move to serverless solution. But yeah, that was a great answer. So we have a question from David. Could you use also Azure Traffic Manager for balancing at DNS level?
There's as well on Microsoft Learn as well. There's a good article about Azure Front Door, about gateway load balancing. There are four resources you can use, and it's honestly, I'm struggling with which one is now available for what. Maybe you know it. I guess DNS level is available for Azure Traffic Manager. I'm not 100% sure, honestly.
Yeah, I believe it really depends what type of traffic that we would like to pass through these kind of balancing. Traffic Manager is a kind of DNS level and some part of the other part of things as well. But yeah, in some solutions, maybe you can use Traffic Manager, but there are some limitations of Traffic Manager, even if it's working with DNS level. So you need to choose basically front door instead of that. So that's the point.
Yeah.
More question. Does auto scaling feature has any relation with Azure Functions?
Not really, no. So, auto scaling is available as well for Azure Web Service or App Service plans. Auto scaling is as well available for VMs. So the auto scaling alone is not, it's not serverless. I would say serverless is more the idea of pay as you go, and when you go to Azure Functions and using the Azure Function as a programming framework, I would say it's easier to use, or you can use Azure resources quite easy. So, for example, Cosmos DB, you can just use an attribute to say return it to the Cosmos DB instead of return it as HTTP, for example. So, auto scaling alone is, I would say, auto scaling is an advantage of the cloud in general, and not especially for serverless.
Yeah, that's true. That's true, because this feature is available, as you mentioned, is available for many services that Microsoft already provided. So there is a comment from Navid. He said serverless services is designed for doing just one single work. For example, running code, but in serverful on a VM, we can run code having database and cache. If we run a VM for running just API, yes, the serverless is the best option. So I think it's a good comment, but it really depends what exactly we want to do. Because sometimes maybe we have serverless solution, but this serverless solution connected to kind of, a platform as service like SQL, Azure SQL can be more cost, efficient, instead of having a VM running on cloud and having everything on top of that. But what is your idea? What is your answer here?
I totally agree. So at the end here as well, it depends on your requirements. But for sure, when you want to have a VM and you want to run your code inside the VM and you have cache inside the VM and database, etc., then it could be a totally fine solution for sure. But on the other side, yeah, you need to ensure that the VM, or you need to, everything which is doing Microsoft for you by using Azure Functions, you need to do manually in VMs. So, for example, making some updates, have a look to if everything is fine inside the VM itself. For sure, the infrastructure, the hardware, you don't care about. It's in Microsoft data centers, but everything inside the VM, you need to ensure that everything is fine. And this is something you don't need to do by using serverless. Yeah, at the end, it's a quite good. Yeah, it's not a question, but an information, because honestly, I don't have it in mind. So yeah, thanks.
Yeah, exactly. And from my experience, this is what I've experienced regarding serverless solutions. Sometimes the type of the application that you are going to deploy or implement to your environment, it's enough sensitive that you shouldn't have database together to your application. So it means you have to create isolated VM only for your database, or even use Azure SQL service to be able to use that database solution together with your application. So in this kind of solution, personally, I suggest using serverless solution together a database. So it's really depends on the scenario that you are going to follow in terms of security, efficiency, cost-effective solutions, and so on. So it's really depends. But yeah, sometimes having one VM, having everything on that VM should be a good solution. And
funny thing as well, I mean, you can run Azure Functions as well in Docker, or for example in VMs, but this is another topic.
yeah, that's true. So yeah, the last question that we have, what is an endpoint? This question came up when you explained the Azure front door. So I think it's related to that one. What is an endpoint? Can you give example and explanation on that, on the same?
Yeah, I can go to the page here. Yeah, so when you just create an Azure front door instance, you just see this page. And when you go to this front door designer, yeah, it's front door domains, front end. Every time front end and front door. So front end domains is the front end of this Azure front door. So at the end, as you saw here, Azure 0 to hero, Azure fd.net is the URL I'm calling via Postman. So this one here. And the /API/get data is just forwarded to the to this instance of this Azure function. And the backend pool is just a list of our internal services. So it could be, for example, an Azure function, it could be an app service, it could be a VM for sure as well. So at the end here, we just define what is our backend, and then we have this routing rule. And what is the question with endpoint?
Yeah, what is an endpoint? I think that's mentioning about this backend poll. If we are thinking about the same things in Azure front door.
Yeah. So maybe this I can explain. So as you see, we have here functions in the backend the backend pool. We have these functions, and as you can see inside the Azure function here, we have the functions. Oh no, it's changed. They changed it. I guess it's here. Yeah, function. So we have get data, and as you can see, we just have these URL without any /API/get data. So this one is the endpoint we call via the front end, and then front end just via front door, and then we just forward it to the https azth west Europe Azure websites, and then we take this one, add it here, and then we call this endpoint. And this endpoint is just declared inside the Azure function via function get data, and inside the program CS, I guess, because we use configure function. No, because we. I guess it's per default. Yeah. Yeah. So this is the reason at the end.
Yeah, exactly. And yeah, that's true. So for each function, you can create different endpoint. And if you're familiar with like API concept, it's a kind of the same concept that you can use for your Azure function. And also Florian mentioned that it's really good if you want to create like microservices function will help you a lot in terms of having several solution connected to different endpoint. But yeah, I think we went through all of questions, and we don't have any more question. And it's your time, Florian. You need to choose the best question so we can award them.
Can I only select questions, or can I select the information from Navid as well? Because honestly, I liked it, because as I talked at the beginning, I learned something about it, and it was not in my mind. So honestly, this is quite the best information, not a question, but information.
Yeah, it's your choice, so no problem.
Then I will take this one. Nice.
Okay, then Navid, we will contact you. We have your email information on your registration form. So basically, we will contact you, and you're our winner today. So we will send you the voucher of the Microsoft exam for both fundamental and advanced, which is 50% discount on any type of exam on that level. So thanks again, Florian. It was a very great session, and we learned a lot from you. Hope we can see you again on Microsoft Zero to Hero stage soon. And yeah, wish you a great weekend.
Thank you. It was a pleasure, and I looking forward to see you again. Nice.
Amazing.
Thank you.
Thank you so much, beautiful people, and have a great weekend, and see you soon on new episode of Microsoft Zero to Hero for September very soon. Take care. Bye.